Namaste everyone. Today we are going to do Riemann Sums challenge. So let's start by doing area of the shaded region is given by the integral rate of 3 ln of x dx. Its value can be approximated by using trapezoids. Which of the following expressions equals the sum of the areas of the trapezoids in the diagram? Okay, so these are the sums. Let's calculate the area. Let's start by calculating. Okay, so first let's find the area of the first trapezoid. Its delta x is equal to 2. So let's just it like this. This will be first trapezoid's area is equal to area of the first trapezoid is equal to, it will just be equal to 2 times f of 2. I want to find out what is 3 ln of 2. Ln of 2. Okay, so that is 3 is 2.07. But let's just say this is equal to 3 ln of 2. So this will be 3 ln of plus, when at 4 it will be 3 ln of 4. 3 ln of 4. This thing will be divided by 2. These two will cancel out, and the area of second trapezoid will be equal to 2 times 3 ln of 4 plus 3 ln of 6. Okay, so this will be divided by 2, cancel out. The area of the third trapezoid will be equal to 2 times 3 ln of 6 plus 3 ln of 8 divided by 2. So out again, we are just left with this will be ln of 2 plus 6 ln of 4. 3 ln of 2 plus 6 ln of 4. We can just take common 3 in all. Let's just rewrite it. It will be 3 ln of 2 plus 6 ln of 4 when we add these all, plus 6 ln of 6 plus 3 ln of ln 8. Okay, so when we just take out a common 3 in these, this will just be equal to, okay, so this will be 3 times ln of 2 plus 2 ln of 4 plus 2 ln of 6 plus, this will be 2 ln of 6 plus 3 ln of 8, not 3, just be 1 plus ln of 8. So let's just see which one. 3 ln of 2 plus 2 ln of 4 plus 2 ln of 6 plus 1 ln of 8. So this looks correct. Let's start by doing. A cyclist starts pedaling and accelerates for 12 seconds. The table below gives the velocity v of the cyclist in feet per second at time t in seconds. The area under the velocity versus time curve gives the distance the cyclist travels in 12 seconds. Let's use L of 6, the left Riemann sum with 6 equal subdivisions to approximate this area. Okay, we just need to 6 equal subdivisions. So when we use 6 equal subdivisions, this will just be equal to 0 to 2. This will be 1 equal subdivision. This will be 2, 3, 1, 2, 3, 4, 5, 6. Yes, this will be equal to 6 equal subdivisions with a left Riemann sum. With left Riemann sum, so this will just be equal to, okay, so this will just be equal to 2 times 2 times 4 minus 0. So when we say that this is a velocity versus time graph, this will be like this. This will be equal to t and this will be equal to v. This will be the velocity and this will be the time in seconds and this will be feet per second. When this will be when time is equal to 0, velocity is also equal to 0. When time is equal to 2, velocity is equal to 4, like this. And when this is equal to 0, 0, and when we come at 2, then this time, sorry, this when this velocity is equal to 4, then time is equal to 2. So this will connect the dots like this. Will be the graph. Okay, so we can just fit. Okay, so when time is equal to v, when time is equal to 0, velocity is also equal to 0. C and this v. When time is equal to 0, velocity is equal to 2. Okay, so this will take this 0, 2. When velocity is 0, when time is equal to 2, 4. Okay, so and when time is equal to 4, velocity is 5.5, and when time is equal to 6, velocity is 6.5. When 8, then it will be equal to 7, and when 10, it will be equal to 7.5, and when it will be equal to 12, then 8. Okay, so when we connect the dots, like this, and we have to do it with 6 equal subdivisions. Okay, so 6 equal subdivisions, what will be it equal to? Okay, so like this, it will just be like this, and with 6 equal subdivisions with the left Riemann sum, this will be 0, and this is just equal to 0. The first rectangle's area is just equal to 0. Let's just see. 1. From 2 to 0, its uh, width is equal to 0, 2, and times its height. First one it's 0, and we are using a left Riemann sum, so this will just be equal to 0. First is equal to 0. Is see in this one. Yes, in this one we can see that this is the graph of this table. Okay, so we will just see this time. So this is the graph of this one, and we can just see that this is 0, 0, and this is 2, 4. And if we take it with left Riemann sums with 6 equal subdivisions, this will be the first equal subdivision, second, third, fourth, fifth. This will be the sixth. Okay, so when we do like this left Riemann sum, it's the first area is equal to 0, because its starting point is equal to 0. and when we take the second point from 2 to 4, we will see like this. This will be from 2 to here, its height will be equal to 4. So 4 times 2, so 4 times 2, 4 times 2, it is just equal to this rectangle's area. This is left Riemann Sum rectangle area. So its area will be equal to 2 times 4. It is equal to just 8. This will just be equal to 8. So we can just write it like this. First rectangle's area is 0 plus second rectangle's area is equal to 8, and the third one from 4, from this point 5.5, from 5.5 to this is 6.5. This is just 6.5. So we can just like this. From here to here, what is the area? Its width is equal to 2 times 5.5. 5.5 times 2 is just equal to 11. So we add it with 11, and this will just be equal to from 6.5 to here. So this will be 6.5 times 2. This will be equal to 13. Add 13 to this also. We added 13 to this also, and this will be okay from 7 to 7.5. So this will be 7 times 2. This will be plus 14. 14, and this is just equal to 7.5. 7.5 times 2, it is just equal to 15 plus 15. And if we add these all, and if we just add these all, and if we just add these all in our fix, this will be equal to 0. This will be equal to 0, 0 plus 8 plus 11 plus 13 plus 14 plus 15. Okay, so we just add these all. What will it become? It will be equal to 61. And what is the value of L of 6? It is equal to 61 feet. This is equal to 61. And if our answer, the distance traveled in 12 seconds is, what is the exact? What is the exact distance traveled in 12 seconds? Well, what is it equal to? Less than L of 6, because L of 6 overestimates the exact area, or equals, because L of 6 is the exact area, greater than L of 6 because L of 6 underestimates the area. Yes, we saw that L of 6 was underestimating the area. Okay, so this will be this will be greater than L of 6. The real distance will be greater than L of 6. So let's check our answer. Correct? Okay, so let's just next. Let's just next. The graph of f of x shown below is increasing and concave up on its domain. Okay, and concave up on its domain. The area of the shaded region can be approximated using rectangles of trapezoids. Ranking in order from smallest to largest, the following quantities: L of 3, the left-hand rule with 3 equal subdivisions, M of 3, and we have to just see what is, we have to rank them in order. Okay, so first let's see what L of 3 is. So this is the graph. We have to see what L of 3 is. We start from with 3 equal subdivisions, so this will be equal to, we are going from 1 to 7, I think. Yes, I think from 1 to 7. Yes, from 1 to 7. So if we do 3 equal subdivisions, so this will be 7 minus 1 is 6 divided by 3 is equal to 2. Okay, it like this. And if we do like this will be the first rectangle, and the second rectangle will be just like this, and the third rectangle will be like this. Okay, so this is L of 3. Second one we have to do is M of 3, the midpoint rule, 3 equal subdivisions. So this was the L of 3, and let's do M of 3. M of 3 will be just like this. First rectangle will be same, and the second will have a little bit change. Let's just do M of 3. Okay, so let's just write L of 3 is in black. Let's do M of 3 in blue. This will just be the same, and midpoint of this will be just like this. Yes, just like this. And if we do the third one, it will just be like this one. Yes, like this one. So this one is M of 3. So one is M of 3. And let's do the next one. The next one is R of 3, the right hand rule with 3 equal subdivisions. Okay, so let's do the next one, R of 3. Okay, so the R of 3 will be in this color, R of 3. Okay, so right hand third one. Okay, so when we do the first one, this will just be like this one, and the second one it will be like this and this one. If we do the third one, this will be just like very big one, then here, then here. Okay, so this one is R of 3. Let's do the next one. The next one is T of 3. T of 3 is the trapezoidal rule. Okay, so next one will be T of 3. T of 3. This will be the trapezoidal rule. The trapezoidal rule will consist of from 1 to 8, 1 to 7. It will be 3 equal subdivisions. 3 equal subdivisions will be from 2 to 2. Okay. The trapezoidal rule will just better approximation. It will just be like this, followed by like this. It will be like this, followed by till here, and then till here, followed by the very big one, and it would be a better approximation than all these. So let's just put them in order. The smallest one was the left one. Yes, the smallest one was the left one, followed by the right one was bigger than them. Okay, so the first one is left. We have to do from smallest to largest, so smallest is L of 3. Yes, L of 3, followed by the midpoint rule. R of 3 is the biggest of them all, and then comes the trapezium one, and then comes after this figure, then the biggest one is R of 3. Okay, so this one was wrong. T of 3 will come after this or not? What will be happening? Okay, the first L of 3 is the best one, and then M of 3 will come, followed by, okay, first T of 3, then M of 3, then this one, followed by this. Okay, so L of 3 first, then trapezium, then midpoint, then which one will come? Okay, so trapezium was smaller than this one, midpoint was bigger than that, point was also small. Smallest one, can we get midpoint? R is the biggest of them all. Can we get trapezium? Okay, so let's just do it again. L of 3 followed by M of 3 followed by this one, then R, trapezium, then R1 is the biggest, L is the smallest, followed by comes 1, then trapezium, 1, then R of 3. Let's just see. This one is R of 3, it's certain bigger. M of 3 is smaller than this one, than the actual one. The real one we already know. With this we know that L of 3 is smaller than M of 3 is smaller than R of 3. Trapezium and this one are between L of 3 and R of 3. Thus our goal is to rank M of 3, T and T of 3, and these are from smallest to largest. With this it follows that L of 3 is smaller than M of 3, smaller than this, then for smaller than T of 3. Okay, so T of 3 was bigger than that, was bigger. First L of 3, then M of 3, this one, then followed by T of 3, followed by R of 3. If the function f is continuous on its domain, in terms of k, certain functions' values are given in the table below. If the trapezoid approximation of the integral from 0 to 10 of f of x dx with 5 equal subintervals is t of 5 is equal to 50, then what is the value of k? What is the value of k then? T of 5 is equal to the addition of all these. In terms of k, certain function values are given in the table below. Okay, so we know that the delta x is equal to 2, so it will just be equal to, this will just be equal to 2k. When we add these all in the formula, it is that it will be equal to 2k plus it will be 2 3k, it will be 6k then, plus 2 4k, it will be 8k then, plus 2 2.5k, it will be 5k then, plus 3k plus only k, and this will be the area, I think, and add these all. This should be equal to 50. This should be equal to 50. 5 equals, so this will be equal to 50, and if we add these all these k's, then what will it become? 8k plus 2k is 10k, 10k plus this will be 4k, 4k plus 6k is equal to 10k, so 10 plus 10 is 20, 20 plus 5 is 25k, and then k is equal to just equal to 2. K is just equal to 2. Right. Okay, so the challenges. Hi everyone.